Welcome to Rges Algebra 2. This is Lesson 19A. We'll be discussing sections 5.5 and 5.6 regarding direct variation and inverse variation. Now, when we talk about direct variation, we're thinking of situations where as the first variable increases, so does the second. Let me go ahead and write an example and explain this to you. So perhaps a good example of direct variation as x increases, y increases would be, let's say the price of an auto mechanic per hour. As you use him for 1 hour, your price would be so much, and as you use them for 2 hours, as your time increases, so will the cost. Okay, so the way we're going to solve direct variation problems is we're going to use this formula, y equals k times x, where k is a constant. So let's say your mechanic costs $3 per hour. Yeah, don't we wish? $30 per hour, we would say y equals 30x, something like that. Now, oftentimes, what we'll do for a direct variation problem is you will not be given the k right away. You'll be given a y and an x, and you'll solve for k, and then you'll plug it back in to solve again. Let me read you the example that they have on page 126. Here he says, if a mechanic always charges at the rate of $40 for working 1 hour, how much should he charge for working 3 3/4 hours? Now, it's very obvious right away from that problem that k is going to equal 40. And then, so we would start again with our original equation. Y, meaning the cost, is going to be k, 40, times 3 3/4. And so I would multiply that out, and I would get a cost of $150. Now, if instead he had said, if a mechanic always charges at a rate of $35 for every 2 hours, then I would come back to this original equation, and I would put 2 hours equals, let's do the opposite. Okay, let's label this here. This would be the cost, and this would be the time, right? Okay, so we would say the cost would be $35 equals k times the time would be 2. We would solve for k by multiplying. It would be $70 an hour. And then if I said, how much would it cost for 3 3/4, I'd go back to the original equation again, plugging in for, what did I say? I would now know k, which is 70, and the time. So I'd plug in here and here, 3 3/4, and I would figure it out. Okay? So again, by summation, what you're going to do for direct variation problems, you're going to always use, that means where one thing increases, the other thing increases. You're always going to use this as your equation. Typically, you will plug in for y and x and solve for k. And then you will either plug in, for the next step, either y or x and k and solve for the other. So if you would plug in y and k to solve for x, so for the variable asked, okay? or you would plug in x and k and solve for y. So that's how you do variation, direct variation, word problems. It would be one of the few times I want you to use your calculator, and I want you to do problems 1 through 8 all. Okay, and so we can talk about those answers and discuss anything you need, but it's pretty straightforward. Now, for inverse variation, we have a different kind of scenario. We have as x increases, y decreases. So the equation you want to use here for these is going to be y equals k over x. An example of that kind of problem would be, let's say, the speed you travel and the number of hours it takes. So as my speed goes up, the time would go down. That would be inverse variation. We're going to do the same 2 steps, however, that we did before. We will solve for k and then solve for the variable in question. So look in your book on page 128. And this question is, if the average speed for a car trip is 50 miles per hour and the journey takes 6 hours, what would be the necessary average speed for a travel time of 5.5 hours? Now, there are other ways to solve these problems, like in proportion or something like that. But direct and inverse variation are really easy to think about this way. So again, let's see, the average speed is 50 miles per hour, and it takes 6 hours. Okay, so we've got, I'm sorry, let me just think if I were thinking this through. We have speed and time, and we know that as my speed goes up, my time goes down, so this is inverse variation. And it says, what would be the necessary average speed? So my question then would be speed if time is 5.5. So we take our first 2 bits of information, 50 miles per hour and 6 hours. So I'll make this my speed and this my time. First step would be to solve for k. I'll plug in these 2 values. My speed is 50 miles per hour. My k is what I want to solve for. My time is 6 hours. I'm going to multiply, and k is 300. My step 2 is going to solve for speed, so I'm going to write the equation down again. My speed equals k over x times, and this time I'll plug in k, which is 300, and x, which is my new time, 5.5, and I will take my calculator out and multiply that, and I'm going to get the speed of 54.54 miles per hour. So you will be asked to do 1 through 8 all on this page also. Again, use your calculator, memorize your 2 equations, know when to use direct variation, know which one indicates indirect variation, and other than that, I think it's straightforward. 2 of them in this section, you're only being asked to create the equation, and number 6 is a little trickier because we have the rate in kilometers per hour, but we have the time in 24 minutes. So don't forget to convert minutes to part of an hour by doing a division, right? And so that all our units match. Okay, give it your best shot, and we'll look at it together when you get back.